So this is sum of October, November 19, paper code WST01, and it is a sum related to histogram. Now if I read properly, histogram shows the time taken in seconds. Can you see the x-axis is representing the time taken
Yeah.
by each of 260 people to complete a puzzle? Now they are asking me to use this histogram and they want me to fill the boxes. That means they want me to find the frequency. Are you with me?
Yeah.
Okay.
Yes.
Whenever I make a histogram, I know that my y-axis represents the frequency density.
Yeah.
Okay. So if I know my frequency density, I would exactly know what is my frequency and that I can use to fill in the boxes if needed or create a proportion for it. Are you with me?
Yeah.
Before I go to anything ahead, I would first check if the classes are continuous. I can see the classes are continuous. There are no gaps in the problem, so the problem is perfectly fine.
Yeah.
After that, even before reading ahead, what will I do? I will write down the formula of frequency density. What is
Hmm.
frequency density?
Frequency density is frequency divided by class width.
It is frequency divided by class width. And when I want to fill the table down, I am looking at filling the frequency. So I will write the formula for frequency also. So my frequency would be equal to frequency density into class width. I hope you're with me.
Yeah.
Okay. Now I will take the first class that I have over here. I have the frequency. I have the class width. I can easily find out the frequency density. So my frequency density would be what? Can you all please calculate for me? Can you tell me the frequency density for
Yeah.
this?
Since the frequency is 20, the class width is 15. So 20 divided by 15, which is 4 by 3.
So the frequency density over here is 4 by 3. Now if I say it is 4 by 3 for the interval of 15 to 30th, are you with me?
Yes.
It means that this line over here represents 4 by 3.
Yep.
Mahad, are you with me?
Yeah, miss.
If I say this line over here represents 4 by 3, and if I count very properly, so you could see one, count the number of boxes for me. 1, 2, 3, 4, 5, 6, 7, 8. So I can say 4 by 3 represents 8 squares.
Miss 8 or 9?
Please check properly. 1, 2,
Yeah, 8.
3,
It's 8.
4, 5, 6, 7, 8. So I would say 4 by 3 units represents 8 squares.
Yeah.
So 1 square would be how much? 1 square would be how many units? I can always
8.
cross multiply it. So it would be 4 by 3 divided by 8. So 4 by 3
Which is
divided.
1 by 6.
So
Miss, I don't understand it.
1 square is 1 by 6 units. Look properly. I'll just pause the video and explain.
Okay.
Understand? 4 by 3 is the frequency density of my class interval 15 to 30. Okay. So I would say 8 squares is representing 4 by 3. Yeah. We counted the number
Yes.
Yeah.
of squares. So I said 8 squares is representing 4 by 3 units. So 1 square would represent how many units?
1 by 6.
1 by 6. So every 2 squares would represent how many units? If I talk about 2
1 by
squares,
3.
1 by 3.
so it would be 4 by 3 into 2 divided by 8. So every 2 squares would represent 1 by 3 units. Are you with me?
Yeah.
So can you tell
Yeah.
me 1 unit would represent how many squares?
For 1 by 6.
I say 4 by 3 units represents 8 squares, right?
Yeah.
So 1 unit would represent how many squares? Cross multiply. 4 by 3. So 8 into 1 divided by
Yes.
4 by 3 is going to give me 1 unit represents how many squares?
What does that mean?
I want to know if I want to mark over here 1, 2, 3, 4. So how many squares I should take? 1 unit would represent how many squares?
6.
So 8 into 1 divided by 4 by 3. So it comes up to 6 squares. Are you with me?
Yeah.
Hmm.
Okay. So I know that 1 unit would represent 6 squares. So I will go and mark over here. 1, 2, 3, 4, 5, 6. This is 1. I expect you all to mark together. 1, 2, 3, 4, 5, 6. This is 2. 1, 2, 3, 4, 5, 6. This is 3. 1, 2, 3, 4, 5, and 6. This would be 4. 1, 2, 3, 4, 5, 6. This would be 5. 1, 2, 3, 4, 5, 6. This would be 6. 1, 2, 3, 4, 5, 6. 7. 1, 2, 3, 4, 5, 6. 8. 1, 2, 3, 4, 5, 6, 9. Every 2 squares represents 1 by 3. So this is 1, 2, 3, 4. So this would be 9 by 3. Are you with me? Please do the markings and let me know. I'll wait.
Use the much easier method.
Okay. Now I would check for 30 to 45. I will check this for 30 to 45. If I'm checking for 30 to 45, what is my frequency density? It is going to be frequency divided by class width, that is 15. So
So 145 divided by 15, which is 29 by 3.
this is 29 by 3. Okay, or I would say it is 9 2/3 because it is coming to 9.6666.
Yeah.
Okay, so if you see over here for the second one, this is 9 2/3, which is exactly the same. Are you with me?
Yes.
Okay. So now I have checked and I know that whatever marking I have put and whatever scale factor I have used is correct. With me? Now I want to
Yeah.
find the frequency of this and I want to find the frequency of this. Let's go to 45 to 55. 45 to 55. This is this box. So this box is over here. So it would be 6 and what? 1, 2, 3.
So
I see this is between
6
6 and
plus
7.
1 by 2.
If you see properly, it is between 6 and 7.
1 minute.
Is it between 6 and 7?
Yes, it is between 6 and 7 and 1, 2,
Every
3.
6 boxes represent 1 unit. So this is 3 boxes. So it would be half units.
Yeah, so it'd be 6 by 6 plus 1 by 2.
6.5. Can I say it is 6.5?
Yeah, 6.5.
Now let's talk about 55 to 60. This is exactly 3. Yeah.
Yeah.
So I got the frequency density. Now I will find the frequency. So it would be frequency density into class width. For this class, frequency density is 6.5 into the class width. 45 to 55 is 10. So the frequency would be 65. Are you with me?
Yes.
This is for the third one. Let's go for the fourth one. Frequency would be frequency density into class width. I have my frequency density as 3 and class width is 5. So I would say my frequency is 15.
Yeah.
So I achieved to find out the frequency with the help of looking at the histogram. So there is an alternate way also to do it. Okay. Rather than doing all of this, boys, you all need to help me. Okay. Rather than doing all of this, we first find the frequency density of our first class and we get that the frequency density is 4 by 3. Am I correct?
Yeah.
Yeah.
Okay. Now, if I mark this 4 by 3, I get that every 8 boxes represents 4 by 3. So, my one box would represent how many units? 1 by
1
6,
by 6.
1 by 6 units. So, I know that one box represents 1 by 6 units. Now, I need to find the frequency density of the class 3 and the class 4 by using this. So what will I do? I will mark what I need for class 3. So this is class 1, class 2 and class 3. So I mark this over here. And this is the class 4. So I mark this over here. Correct, Mahat?
Yes, miss.
So we need the frequency density of my class 3 and I need the frequency density of my class 4. We know that one box represents 1 by 6 units. So we will count the number of boxes from here till what we need. So if I go on counting this from here till what we need, we get that this stands at 39 boxes. This is 39 boxes from the origin, and this is 18 boxes from the origin. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 boxes from the origin. We want the frequency density. I know that one box is 1 by 6 units. So 39 boxes would be 39 into 1 by 6. That makes it 6.5. So the frequency density for this one would be 6.5, and the frequency density for our fourth class would be 18 boxes into 1 by 6. So it is 18 into 1 divided by 6. So it is 3. So we can get the frequency density in another way also. And then we can use the formula frequency density into class width to get our desired frequency. So we are doing a revision of the chapter 5, which is your correlation and regression. Okay, so there are four things, the four main things that we do in this topic. Our first thing was our scatter diagram. I hope you remember something about scatter diagram. If not, we are going to do right now. The second thing was our equation of the regression line. Do you remember the equation of regression line?
Y equals mx plus c, right?
Y is equal to A plus BX.
Yeah, a plus b at the same.
A plus BX. The first thing was our scatter diagram. The second thing was our equation of the regression line. Third thing was, do you remember?
Least squared regression line.
Least square linear regression.
Yeah,
Least square linear regression. And fourth was the PMCC, product momentum coefficient of correlation, which tells us the strength of the regression.
yeah.
Okay. So what is correlation and regression basically? So what is correlation and regression? Correlation and regression tells us that we have two distinct variables, x and y. Are those variables related to each other, or are those variables dependent on each other? Okay, and to know whether those variables are dependent on each other or not, we prepare a scatter diagram. So what is a scatter diagram? Your scatter diagram is a graphical representation, and you have two variables. One would be your variable x and one would be your variable y. Your variable y is something that is dependent. So the dependent variable would always be the variable y, and the independent variable would be the variable x. Okay. So it will tell us whether your y is dependent on x. Is there some relationship between y and x or not? So we have scatter diagrams, say for biology scores and physics scores. Can you tell me, is there any relationship between these data?
No.
No. That means the biology score is independent of the physics score. So in this case, we will have no correlation. When we draw a scatter diagram, our data is scattered. That means it moves from here and there. We don't have exact data. Okay, this is our original data. If the movement of the data is going upside, then we say there is a positive correlation. If it is moving downward, then we say it's a negative correlation. And when the two data are not related to each other, we say there is no correlation. Are you with me? Come on, tell
Yeah.
me, is there any relationship between temperature and ice cream sales?
Yes.
When the temperature increases,
Sales increase.
sales increase. That means what is dependent on what?
Ice cream sales are dependent on weather.
So ice cream sales will be what variable? It would be Y and this
Y.
is X.
Yes.
Advertisement budget and sales revenue. Is there any relationship?
Yeah.
Okay. So sales revenue would be Y and advertisement budget would be X. Okay. So we have three types of correlation. One is a positive correlation, one is a negative correlation, and one is no correlation. Now, when I have my data, I plot the data point. So every point over here would have one independent variable and one dependent variable. To find the relationship between the two variables, we draw a line, and this line is called what?
Regression line.
This is called the regression line, or I would say this is called the line of best fit. Why is it called the line of best fit? Because the distance between the original data and this line would be the minimum, so it would best describe my data.
Miss, I have a question.
Yeah, tell me.
Does this line always has to touch the y-axis?
Sorry.
Does the line of best fit has to touch the y-axis?
See, this is a normal line. If I draw a line of best fit like this, possibly Haris can draw it over here. You can draw it over here. So this is an estimated line. This is our predicted line, okay? And this is the original data. So anything that is away from the line of best fit is the error. Are you with me? Line of best fit is the estimated line which, according to us, best describes my data. It can start from anywhere depending upon the data because the data is scattered. Are you with me? Are you with
Yeah.
Okay. In this, we may also have an outlier. If
Yeah.
the data is somewhere over here or the data is somewhere over here, then this would be an outlier. Line of best fit is also called the trend line. We use correlation and regression, or we use this scatter diagram in many areas. When we want to determine the relationship between two variables, people in the business use it, people in education use it. They determine study hours with exam score. Okay, and then you can predict values in the future. Say, can you tell me the dependent variable and the independent variable over here?
Exam scores is the dependent variable and study hours is the independent variable.
So this is my study hours and this is my exam score. So I would say if I study 1 hour, 2 hour, my data goes something like this. Okay. And when I am actually finding out the data and plotting the points on an XY axis, I make a line of best fit which looks like that. Now, with the help of this, I can predict what can happen if somebody studies for 2.5 hours. They might get an exam score which would be equivalent to this. Are you with me?
Yeah.
If somebody studies for 8 hours, can this prediction happen over here?
What?
If somebody is studying for 8 hours, can I predict from this scatter diagram?
8 hours? No, it would be an outlier.
It will be outside my it would be outside my study area, so it is outside the range, so it will be extrapolation.
Yeah,
Okay, so you
extrapolation,
can
sorry.
predict only when it is interpolation, that is intrapolation, that is when it is in this range. If it is outside the range, then the prediction is not possible. Okay, even in the health section, we use this scatter diagram to determine the relationship between two variables. I hope you are with me. Now we have different types of correlation. If it is going down, then it is a negative correlation. If it is going down like very, you can actually make the line of best fit with very little errors, then it is strong negative correlation. Okay, if you see over here, you can make a line of best fit, but the number of errors would be more as compared to here. So this is weak negative correlation. Similarly, you have zero correlation, weak positive if it's going up, and strong positive. So can you tell me how many types of correlation do we have?
We have, I've been answering the whole time.
5 types of correlation, please.
Strong negative correlation, weak negative correlation, zero correlation, okay, weak positive correlation, and strong positive correlation.
Okay, fine. Can you tell me what type of correlation is this?
Weak positive.
This is gonna be weak positive, yeah.
This,
Weak negative,
Weak negative.
this,
no correlation.
this,
Strong positive.
strong positive correlation. Okay. Now, another thing is that let's take this as an example over here. Can you tell me an outlier over here?
An outlier would be the circle one.
The circle one. My shop manager wants to use this graph to predict ice cream sales when there is 5-degree temperature. Comment on
Yes,
the
Extrapolation.
validity of his prediction. This is extrapolation. Why?
because it's outside our range.
Because it is outside our range of data. So if something is outside our range of data, the prediction would be unreliable. You need to know this. Okay. Can you tell me what type of correlation this cartograph shows?
Weak positive correlation.
It shows a weak positive correlation. Okay, very good. Now over here. Describe correlation between distance and population density.
Distance.
Distance and
Uh,
population density.
it has a weak negative correlation.
Has a weak negative correlation. So when they ask you to state the correlation, you state it. It's weak positive or weak negative. But when they ask you to interpret the results, can you tell me what is dependent on what?
Um, the distance, sorry, the population density is dependent on the distance.
Distance from the center.
Yes.
Okay, fine. So what is your interpretation?
Interpretation would be as the distance from the center increases, the population density decreases.
So as you're moving away from the center, as the distance from the center increases,
Yeah, our population density decreases.
population density decreases. Are you with me?
Yes.
Okay. Now give one reasons why Hiduku's conclusion might not be valid. Hiduku says that the data supports the conclusion that more education causes people to earn a lower hour rate of pay. What is Hiduku saying? That if I have more education, I will get lower pay.
Yeah.
So give one reason why his conclusion may not be valid.
Because people with higher education get better jobs.
Yeah.
Okay, fine. Now, if you see this very clearly, according to this diagram, okay, the age at which I'm leaving education. If I'm leaving education at 16, I'm getting paid 15. If I'm leaving education at 18, I'm getting paid 11. So if I'm leaving education later, I am getting paid lower. There's a weak negative correlation between this. It's a weak negative correlation. Why would this be valid and why is it not valid?
Hidiko's conclusion is not valid since the people who have left education later have shown to have significantly less work experience than those who left education earlier, and this could cause them to earn lower wages than people who left earlier.
So those who left later, okay,
Yes.
those who left later, they have less work experience,
Yeah.
so less pay.
Yes.
But can this be like good for a big amount of data?
For a big amount of data, this, what do you
Those
mean?
who
Would this
leave
be good?
the education later are more educated.
Yeah,
If they're more educated, they will have more pay,
possibly.
possibly. So this can be valid because maybe she has used a very small sample size of opportunistic data for her study. Okay, but this might not be valid for a larger sample. Correlation and regression, our 5.1 was related to the scatter graph, which shows that y is dependent on x. X would be on the x axis, and y, the dependent variable, would always be on the y axis. Are you with me? Okay. If
Yes.
our data is within the range, then it is interpolation and our estimate is reliable. If our data is outside the range, then it is extrapolation and our estimation will not be reliable. Okay, we have a scatter graph, and for this, we make a line of best fit, which would look something like this or something like this.
Yeah.
If you see, this line of best fit is a linear line.
Yes.
Okay, so this is called a linear regression line, which helps us to identify relationship and to make predictions. This is a linear regression line. I can identify relationship. If it is going up, it's a positive relationship. If it is going down, it is a negative relationship. If it is going up, that means increase in x would lead to increase in y. If it is going down, that means decrease in x would lead to decrease in y. Yes or a no?
No, miss, it would be increase in X, decrease in Y.
When x increases, y increases positive.
Yeah, I'm talking about negative.
X increases, oh sorry, x increases, y decreases negative.
Yeah.
Okay, so
This is for negative correlation.
yeah, if x is increasing, y is decreasing. So this regression line helps us to identify relationship, make predictions. But when you're making predictions, you should understand that your data should be within the range. Only then your data will be reliable. Otherwise, it will not be reliable. And we can use this data to make other forecasts. Are you with me? Are you
Yes.
with me? Now, when I am making my regression line, I say my regression line, the equation of a normal regression line, linear line, is y is equal to mx plus c, where c is my y intercept. But over here,
Yes.
we will use it in the form of y is equal to a plus bx. Are you with me?
Yes.
And if I want to correctly make it, then I will add the errors. Plus E, because this was our predicted data and our original data would be somewhere scattered around the line of best fit. Are you with me?
Yes.
If my regression line is y is equal to mx plus c, or I would say ax plus b, okay, and my b is 4, That means my y-intercept is 4. What does this mean?
It means that this is where the line starts on the x-axis.
It means that this is where my
Y-axis,
line
sorry.
is going to start at. It is 4 units at the vertical distance from the x-axis.
Yes.
And even when x is 0, this is going to happen.
Yes.
Can you give me an example of this?
Example of
Even
x
when x
equaling
is
to 0.
0, this is going to happen. The y-intercept is going to happen.
Yeah, so if you plug in the value of x equals to 0 into the equation, it's gonna give you y equals to 4.
Can you give a real life example for this? A real life example for this is that even if you study for 0 hours, you're going to get 4 marks.
Yeah.
Okay. We say our equation is y is equal to a plus bx. Are you with me?
Yes.
Okay. So B is my slope. What does this tell me?
It tells you how many times uh, y increases when the value of x changes.
Okay. So as x changes, your y will change b times. Are you with me?
Yes.
Okay. So 4 is the distance from the x axis. It is the place where my line crosses the y axis. 4 is my y intercept. It tells me when x is equal to 0, y is equal to 4. Are you with me? Mahadharis?
Yes.
My slope is 2. What does this 2?
Yeah. That 2 means
Every
whenever
increase of x,
x is multiplied, it's times 2.
every increase of x, y will increase 2 times. When my
Yes.
slope is 2, it means that every increase of x, y will increase 2 times plus this. Don't forget to plus this.
Yeah.
If my y-intercept is 9, what does it mean?
That means our line starts from y equals to 9.
Y is equal to 9. That means when x is equal to 0, y is equal to 9.
Yes.
Okay, if my slope is 8, what does it mean?
That means that every change in x is gonna be multiplied is times
Every
8 for
increase
the
of
value of y.
every increase of x, y will increase 8 times. Please use these words. These will help you answer the question. If my slope is 8, it means every increase of x, y will increase 8 times. If my slope is 0, what does it mean?
Uh, Horizontal line.
What does it mean?
It means that no matter what, y will not increase. The value of y will stay the same, even if x
If x
increases.
is 0, y-intercept is definite to happen. What happens if you change the slope? What does the slope decide?
The
This,
gradient.
Okay, so if we're changing the slope, we basically change the sensitivity of y on x. Okay, the slope tells us how fast my y will change or how slow my x will change. Sorry, how fast my y will change or how slow my y will change depending upon the change in x. If the slope is greater, my y will change faster. Yeah. If
Yeah.
I change my slope, say my initial slope was 4. If I change it to 5, that means y will change 5 times instead of 4 times. So y will change faster. If I change my slope from plus 4 to minus 3, that means y is going to change slower.
Yeah.
Okay, so if I am changing the slope, that means I'm changing the sensitivity of the change. And we always find y on x. How will y respond due to the change in x? In regression, if they we will be given the value of x and we have to find y. For given value of x, you have to find y. But in regression, if they give you y and ask you to find x, that is not possible. Why is it not possible?
Miss what?
In regression, we find y on x. That means for every change in x, y changes xyz time. Yes,
Yeah.
that means we would be given the value of x and I have to find y.
Hmm.
Y is dependent on x.
Yes.
But if the in regression, correlation regression, if they give you y and they ask you to find x, is that possible?
No, it's not possible.
You will not, because y is dependent on x, x is not dependent on y. If you want to do this, you have to change the entire equation. Okay, quick check. If the slope is 12, means what?
Y will increase 12 times.
Huh?
If the slope is 12, Y will increase 12 times.
If the slope is for every change in x. Okay. If the slope is -8, means what?
The Y reduces by -8.
8 times for every change in x. Okay. Now, let's talk about our data in the real world. This is our data in the real world. Yes.
Yeah.
So, a data in the real world is a series of x and y observation, and it follows a linear pattern, linear regression pattern. So, when I make the line of best fit, it is called the linear regression model.
Yeah.
It is called the linear regression model, and this line of best fit may sometimes intersect my data in the real world, and sometimes it might not intersect the data in the real world.
No, what do you mean by that?
This is my line of best fit.
Yeah.
This is the data in the real world, which is a series of x and y observations.
Okay.
This is an estimated line.
Hmm.
It may sometime intersect my data, sometimes it may not intersect.
Yeah.
Okay, and what we try to prepare is we try to prepare a line wherein we can try to minimize the distance between the original data and the line of best fit.
Yeah. Yeah.
Okay, when we try to minimize the distance between the original data and line of best fit, it is the linear regression model.
Okay.
But when I try to minimize the squared distance between the original data and line of best fit, then it will be
LSLR.
LSLR. What is LSLR?
Least squared regression line.
The square regression line. So if I want to know my actual line of best fit, it would be A plus BX plus the errors. Are you with me? One thing very
Yeah.
important, we use this linear regression model, that is y is equal to bx plus c or y is equal to ax plus b. Okay, to estimate values of y. Never in correlation regression try to estimate values of x. You cannot use the linear regression model to estimate the value of x for given value of y. Can you tell me why? Anybody?
Yeah, because Y is dependent on X and X is not dependent on Y.
So we will always predict the value of,
Y,
for
the
positive
dependent variable.
correlation, our gradient should be,
For what?
Positive correlation gradient should be positive.
Positive.
For negative correlation, it should be,
Negative.
if our data is within the range, then it is,
Interpolation.
if it is outside the range, then it is.
Extrapolation.
Our line of best fit is basically the mean of x and mean of y. It is the intersection of mean x and mean y. Okay, so this is all in 5.2. Let's go to the LSLR, least square regression line. Okay, when I have the linear regression model, my line is defined by the formula y is equal to ax plus b, which tells us that even if x is 0, my data, the b would always happen, the y intercept would always happen. And the slope tells us how much the y will change, how many times the y will change because of change in x. Are you with me? That is there in the linear regression model. It tells us the meaning of the y-intercept and it tells us the meaning of the slope. Now, when I talk about the least square regression line, here our motto is what? This is my line of best fit. LSLR tries to minimize the square gaps between the original data and the predicted data. That means these are my original data. Can you see this? When I square this original data and then I draw the distance, I want the minimum distance, and what would be that minimum distance when I plot that line is given by LSLR. Are you with me? Least square regression line. So least square regression lines tries to minimize the square distance between the original data and the predicted data. I hope you are with me.
Yes.
So when you're doing the least square regression line, I will already have the equation of the regression line, that is y is equal to a plus bx. Are you with me? Hello.
Yeah, miss.
Are you with me? Y is equal to a plus bx will be given to us. Now I want to minimize the square distance. That means I have to find the new y, new a, and new b. At least answer in yes or no so that I know I should
Yes.
proceed or
Yes,
not.
miss.
I have to find new y, new a, or new b. And I know my regression line, that is my this line, is an intersection of mean x and mean y.
Yeah.
Okay, so when I'm making my new regression line, it would be mean of y is equal to a plus b mean of x. LSLR.
Yeah.
Miss, before you said y bar, I mean y is equal to ax plus b.
Y is equal to ax plus b is equal to a plus whatever variable. These are constants. I can use any variable. These are constants. I can use any variable. It does not matter whether I'm using a plus bx, ax plus b, mx plus c, anything I can use for constant. Okay?
Okay, miss. My bad.
Here, now I am trying to find the new line, new a and new b. A and b are called the regression coefficients. What are they called?
The regression coefficients.
Okay. So the first thing that I will do is I will find new b. How do I find the new b? That is the new slope, the slope of this regression line, which is an intersection of mean x and mean y. It would be sxy over sxx. Are
Yeah.
you with me? This would be my
Hmm.
new slope of the regression line. So this is my first regression coefficient. My second regression coefficient would be a. How will I get my a? That is the y-intercept. It would be mean of y minus b mean of x. I'm giving you 2 minutes time to write the regression equation and how to find the regression coefficients. Write it so that you understand what I say later. There are 5 things that you need to find when you're doing LSRL, least square regression line. First, you write your regression equation, that is y is equal to a plus bx. Then you find your b first. B would be sxy divided by sxx. How do you find sxy? Sxy tells you how your x and y varies together. So it would be summation xy minus mean x sum y divided by n. And sxx, how x varies with the x. It would be summation x square minus sum x divided by n the whole square. I hope you are with me. So first you find b. Can you tell me what is the b?
B is the slope.
Okay, then you write the equation all over again and you find the mean y, mean x, plug in and find a. Can you tell me what is a?
A is the y-intercept.
A is the y-intercept. That means you find the new slope, you find the new y-intercept. To find the new slope, you want to know how much your data x and y varies with each other and how much x varies with x. So you find the new slope by using this formula. You find the new y-intercept and you have the new equation. Are you with me?
Yeah.
One more thing. You find the regression line of what? Y on X. Are you with me?
Yeah.
I find the regression line of Y on X when I am finding B. Are you with me? I write BYX. It
Hmm.
means I'm finding the slope of Y on X, this line. Are you
Yeah.
with me? But when I write SXY, you will always remember SID. Then this variable Y would be the dependent variable and X would be the independent variable.
Yes.
If I have SFT, what is
S
independent and what is
F D.
dependent?
Independent is F and D is dependent.
Okay, so the regression equation line would be what on what?
It would be T on F.
That means T is equal to A plus BF.
Yeah.
Yeah?
Yeah.
So how would you find your B?
I would find my B by one.
You would find your B
Yeah,
by
you would find your B by S F T divided by S F F.
SFT divided by SFF. So this would be all regarding your least square regression line. You're finding the whole new line all over again.
Hmm.
Okay. And the regression coefficients would be your new A and new B. New A would be mean of X and mean of Y, and you model the equation. And
Hmm.
new B would be SXY over SXX. This is all that you do in least square regression line. Your last
Yeah.
one is your product moment coefficient of coefficient, correlation coefficient, that is PMCC. Okay.
Yeah.
You know that your relationship could be a positive, a negative, or there should be no positive correlation, weak positive, weak negative. Okay. But how strong is the relationship between your variables is given by the word R. PMCC. The product moment correlation coefficient is called the R. R
Yeah.
tells you the strength of your relationship between the two
Between your yeah, your data.
the variables. And here your regression coefficients are A and B. So your
Mm.
strength would vary between -1 and +1. Okay. If R is equal to 1, it means there is a perfect positive correlation.
Yeah,
If it is -1, then perfect negative. If it is
correlation.
0, then there is no correlation. If it is greater than 0, then positive, and less than 0, then negative. I hope you're with
Mhm.
me.
Yes.
So the strength would vary between 1 and -1. If R is 1, what does it mean?
If R is 1, it means it's perfect correlation, perfect
Perfect
positive correlation.
positive. 0,
No correlation,
-1,
perfect negative correlation.
perfect negative correlation. Now here you should remember that your thumb rule is for zero point 0.7. Okay, 0.7. Perfect
Mm.
would be 1 and -1. Okay, if it
Yes,
is 1, then it is perfect positive. If it is -1, then it is perfect negative.
yes,
Okay, but if it is less than -zero point 0.7, then it is strong negative.
yeah. And if it's more than
Zero
uh,
point 0.7,
plus
then
zero point
strong
0.7, that
positive.
means it's strong positive correlation.
And below this would be weak positive or weak negative.
Yeah,
Okay, if it is minus, then it is weak negative. If it is plus, then it is weak positive. Okay, another thing, when they ask you to state, okay, when they ask you to state the relationship, you can state it as strong positive or strong negative, or weak positive or weak negative, or perfect positive or perfect negative. But that will not be an accepted answer when it is, when the question typically tells you interpret. So when they ask you to interpret, you will interpret that when x increases, y increases or decreases. This is the way you interpret it. Are you with me?
yes.
What is your regression coefficient? Can you tell me?
My regression coefficient in
My regression coefficient is
it
A
tells
and
me
B,
the relation. Yeah, A and B.
and PMCC is your R, product
Yeah,
moment coefficient of correlation. What does the PMCC tell you?
it tells me the relationship, how positive, how
The strength,
strong
the
the
strength,
strength
linear
of the
regression
relationship
line.
between the two variables.
Okay, fine. Now understand over here the relationship between coding and PMCC. I have an X, I have a Y. I code the X into P and I code the Y into Q. Are you with me?
Yes,
Then I will get a new value for P and Q which are smaller.
yes.
Okay. If I want to find the strength of the relationship, I will find the PMCC, and PMCC is found by making R.
Hmm.
How do I find R? R is SPQ divided by the root of SPP into SQQ.
This will be
Hmm.
provided in the question, right?
But you know, you should know that when they ask you the strength, you have to calculate the PMCC.
Yeah,
PMCC
okay.
is given by R. If you want to calculate R, you will do SPQ divided by the root of SPP SQQ. If it's not coded, then R will be SXY divided by root of SXX into XYY. Hello, are you with me? Are you with me?
Yeah, miss.
Haris,
What did he say, miss?
what is R?
R is the strength.
PMCC.
R tells you the strength between the two variables.
It's PMCC.
Yeah.
How do you calculate R?
SXY divided by root of SXX into SYY.
Into S by Y. If I code my data X into P and Y into Q, then it would be
Yeah.
S P Q P P Q Q.
Yes.
Yes. So one thing you should note over here, that coding will have no effect on your R. We have done this with examples. So if I find my this as x y x x and y y, and I find my R using this formula, I will get my R as 0.65. And if I find it for PQ also, PMCC for XY will always be equal to PMCC for PQ. The strength of the relationship will never get affected due to coding. Coding can just shift my data from year to year or year. Coding can just shift my regression line either upwards or downwards, but it will never change the strength of the relationship.
And since the data also moves with the line, there's going to be no effect on the PMCC.
No effect on PMCC. So if they give you R, X, Y, and they ask you to calculate RPQ, it will be the same. Are you with me?
Yes, miss.
If they ask you to calculate RPQ, but they give you information about everything related to XY, that is SXXXXY, SYY. So you will calculate R of XY and you will say it's equal. Yes or no?
Miss, could you please repeat?
They ask you to calculate PMCC for PQ, but they give you information of this. So
Okay.
with this information, what can you calculate?
R of X, Y.
Coding will never change your PMCC, so R of PQ will be equal to R of XY. If I code my X into X plus 5, my data will just change from year to year. My line would just change. But the PMCC will never change. If I am coding my data, my regression just translate to have a different equation. But as the data points and the regression lines move together, the extent to which the data fits the line does not change. I hope you remember this.
I
You got
will find R by first uh, opening my calculator, putting it on mode 2, which is okay, and then
you put the values of X and Y. Once you put the values of X and Y, you will press the AC button so that it gets stored in your memory.
miss Aikman.
Mahad, I hope you're doing.
Miss is not doing shit.
It's not also on the revision sheet.
Miss, don't worry, I'm doing it.
Once you put the data, then you press Shift plus 1, choose 5 for your regression. 1 minute wait, okay? So
Okay.
when I'm coding my data, okay, if I add a positive number to the code, there will be no change in my PS. There will be no change in my R, that is the PMCC. If I multiply or divide, there will still be no change in my PMCC or R. Okay, but if I multiply with a negative number, it changes the direction of the regression line. So a positive relationship would change into a negative relationship. Are you with me? It flips the data direction. There is another thing that you should remember. Byx, if this is given to you, this is going to give you the regression equation y on x. Are you with me? So B would be Sxy divided by Sxx. Are you with me? Please answer. If I have Byx, that means I have a regression equation y on x. So B will be xy divided by xx. And if I have Bxy, this means my regression equation is x on y. So B would be Sxy divided by Syy. Okay, and the relationship between Byx into Bxy, if you multiply both of it, you get R square. So sometimes they give you xy and yx, so you should be able to determine. Are you with me? S I
Yes, miss.
S is always the independent variable is first and the dependent variable is afterwards. But for B, it is yx. That means the dependent variable is before and the independent variable is afterwards. You should remember this, and this is all with the revision.